Okay, let's dive right into this explainer by challenging, well, pretty much everything we thought we knew about the geographic origins of modern chemical sciences. When we think about the absolute bedrock of chemistry, our minds usually jump straight to the European Enlightenment, right? Or maybe ancient Egyptian alchemy. But today, we're going to explore a completely different, incredibly advanced, and honestly often overlooked source of early scientific thought. We're heading straight into the heart of ancient Indian chemistry. To really wrap our heads around this, let's just look at the word itself. In the West, it's widely believed that all chemical knowledge stems from Egypt. That's actually what sparked the word chemi, coming from chem, which is an old synonym for Egypt. But the reality in the East tells a remarkably different story. Ancient Indians were already practicing a super advanced form of chemistry known as Rasashastra, Rasasastra, or Rasavada. And this wasn't just some abstract theoretical philosophy either. It was completely practical. They were actively studying the elements of the universe, their physical properties, and their reactivity. And it's heavily evident in their surviving literary works and archaeological sites. So here's how we're going to break this whole topic down today. First, we'll look at the origins of ancient chemistry. Second, intellectual thinking and atoms. Third, professional skills and metallurgy. Fourth, welfare, healthcare, and medicine. And finally, we'll wrap up with the legacy of Rasayana. All right, let's jump into section 1, the origins of ancient chemistry, and its 3 core pillars. What's truly fascinating here is how the ancient rishis actually structured their scientific revelations directly around fundamental human needs. They didn't view chemistry as just some isolated laboratory exercise cut off from the real world. Instead, it was this beautifully integrated system spanning thought, survival, and care. You had agriculture, housing, and weaving on one end of the spectrum, and then profound universe-level philosophical inquiries on the other. Moving right along to section 2, intellectual thinking and atoms. And yes, we are talking millennia before modern physics. Long before modern atomic theory was formalized in the West, an ancient Indian sage named Kanada essentially hit the nail on the head. He propounded the Vaisheshika Darshana. This philosophical school mapped out the core concept of the atom and its absolute indivisibility. It also strictly established the law of cause and effect. And this wasn't just a passing thought they had one day. It became a foundational doctrine. It was accepted by other schools of thought, like the Nyaya theory, which resulted in a massive, rich tradition of commentaries and treatises unpacking these early atomic theories. Now consider this equation for a second. If you've taken a chemistry class, you probably recognize this right away as the modern physical chemistry formula for melting gold using heat. Solid gold plus delta H yields liquid gold. It's the absolute basic law of thermodynamic phase changes. And here is the kicker. This brilliantly illustrates how those exact same phase changes and laws of thermodynamics were clearly stated thousands of years ago. In ancient Sanskrit sutras, they specifically noted that substances like ghee, lac, and beeswax become liquids with the addition of heat. Then literally, in the very next sutra, they state that gold, silver, copper, tin, and lead also convert to liquids when subjected to heat. They were systematically differentiating materials by their high and low melting points and documenting phase changes by their intrinsic nature. That modern equation we just talked about, it's basically a direct translation of these ancient verses. Let's shift gears to section 3, professional skills and metallurgy. Basically, applying chemistry to make a living. The text of the Ayurveda explicitly tells us that Vedic people were actively utilizing 6 specific metals: gold, silver, copper, tin, lead, and iron. As their society grew, agriculture and the demand for better tools absolutely necessitated the mastery of these materials. According to the Chandogya Upanishad, they understood the intrinsic properties of these metals so deeply that they were stipulating exactly how to fuse them together. For instance, they noted that you can join gold with the help of borax and lead with the help of tin. But their understanding went all the way down to the microscopic level. And this is where it gets really wild. The Mahabharata mentions tribal kings presenting Yudhishthira with something called Pimpalika gold. This was a superior quality gold collected by ants from termite mounds. The ants would naturally dig the earth, bringing up microscopic gold particles that were then deposited in heaps. Modern scholars analyzing these exact texts realized they were describing a process that strikingly parallels what we now call nano gold. That's a highly specialized material with enormous modern industrial applications, and they were already onto it. On top of that, Kautilya's Arthashastra reveals some incredibly sophisticated mining and metallurgical techniques.
The director of mines was expected to be an absolute expert. They identified ores not just by density, knowing heavier meant more metal, but by highly specific colors and textures. For example, an ore that was crow black or, get this, the color of a dove smelling like raw flesh was categorized as lead. An ore that was greenish, reddish, or tawny was copper. They even judged the purity of gold by its color. Gold the color of a lotus filament was best, while red or gold meant it had a higher unwanted copper content. The artisans back then were, for all intents and purposes, true chemical engineers. They weren't just smashing rocks together. They were precisely mixing molten metals into exact calculated proportions. Take a look at this breakdown for minting silver coins, dictated by ancient texts. 11 parts silver, 4 parts copper, and 1 part iron, tin, or lead. That is a highly specific 16-part formula, demonstrating a profound, repeatable mastery over chemical alloys. Okay, moving to Section 4, Welfare, Healthcare, and Medicine. The absolute science of survival. Just look at the staggering scale of their scientific categorization here. This is taken from the medical treatise known as the Charaka Samhita. We're talking about hundreds of highly specific entries, 150 types of diseases, 341 medicinal plants, 177 substances of animal origin, and 64 of mineral origin. They even categorized 33 varieties of bones and systematically differentiated between types of honey, milks, natural waters, and vegetable oils. The whole shebang was methodically classified based on physical characteristics and their precise medicinal utilities. And we obviously can't talk about ancient medicine without bringing up Sushrata, who is widely regarded as the father of surgery. His contributions to human anatomy are just phenomenal. But looking at it strictly from a chemical perspective, what's so fascinating is that he utilized early fermentation products that he administered to patients during operations. These complex chemical mixtures acted exactly like modern anesthesia drugs. This is what allowed him to use the multitude of specialized surgical instruments he designed, many of which are conceptually still in use today. Which brings us to Section 5, the legacy of Rasayana. Let's look at how we're uncovering the past. You see, this knowledge wasn't just lost to time. It was fiercely protected and passed down by brilliant scholars. It started with figures like Nagarjuna, the great alchemist of India and founder of Rasashastra, who really pioneered metal and medicinal plant combinations. This tradition carried on straight through the 8th to 16th centuries with saints and alchemists like Vagbhata and Nityanatha. And finally, in modern times, we have Professor Prafulla Chandra Ray. Known as the father of Indian chemistry, he literally spent his life establishing chemical industries in India and famously published The Hindu Chemistry back in 1919. He meticulously translated these ancient Sanskrit texts, adding his own commentary to prove to the world that these ancient formulas align perfectly with modern chemical science. So as we wrap up this explainer, I want to leave you with a thought to chew on. If the laws of thermodynamics, the practical application of nanomaterials like piplica gold, and advanced surgical anesthetics were already accurately recorded in these ancient texts, what other modern scientific breakthroughs are just hiding in plain sight? As scholars continue to translate the past, we really have to ask ourselves how many of our future scientific discoveries might actually just be rediscoveries of ancient, deeply profound knowledge. Thanks so much for joining me on this deep dive. I hope this completely changes how you view the incredible history of human science.